Alright, so we're on to video number 2. Hopefully you caught at the end of video 1. I was testing you a little bit. When I say that, I mean I messed up a little bit. So let's look back at number B, or letter B here. Okay. So this was the rule here that I came up with at the end of the last video. Okay. And maybe you're saying, well, Mr. Zook, how do we know if that's right or not? Okay. Well, again, we always want to have a good way to check our work. So again, let's use this rule to start writing out the sequence. Okay, and make sure that it actually matches what it's supposed to. Okay, so let's start at a sub 1. Well, that would be, using my rule, 2 to the 1 minus 1 over 1 factorial. Well, 2 to the 0 power is 1. 1 factorial is also 1. Okay, so our first term is 1. Well, that matches, so that's good. Okay, well, let's go on to our second term. A sub 2. Well, that would be 2 to the 2 minus 1 over 2 factorial. 2 to the 1 is 2. 2 factorial is also 2. Well, okay. Here we run into trouble, right? Because this was, our second term was supposed to be 2, not 1. So, in fact, my rule does not work. Okay? Let's try one more term just to see kind of what's going on, see if we can figure out why. Okay? So let's go to a sub 3. Well, now we're looking at 2 to the 3 minus 1 over 3 factorial. Okay. Well, that's 2 squared is 4. I think actually they leave it over there as just 2 squared. Okay. Over, well, 3 factorial is 6. Okay. Well, that looks like almost what our fourth term is supposed to look like on the bottom. Okay. And in general, it looks like all of our denominators are kind of shifted one to the right. Okay. So let's do some erasing here. How can I fix my rule? Okay. Let's go purple. Okay. Well, again, I want to shift that factorial 1 to the left. Okay. So instead of n, let's use n minus 1 factorial here. Okay. Well, that would change a sub 1 to 0 factorial. Okay, well, 0 factorial is still 1, so the first one still works. Well, now our second one, get rid of that, that would become 1 factorial, which is 1. So our final answer would be 2 over 1 is 2. Okay, well, now that matches like it's supposed to. And we can keep working. We're going to see that is actually the rule we're supposed to have. Okay, so whenever you write these rules, once you think you have your final answer, go ahead and, write out a couple terms and make sure they match like they're supposed to. Okay, and it may mean your n needs to be an n minus 1 or an n plus 1. Okay, that's not too bad of a check. Okay. So let's go ahead and do some erasing here. All right. Okay, I do want to do example C here because it's one we haven't quite seen yet. Okay. So this is like that example we mentioned earlier where we have that alternating sign. Okay, so we go from a negative 1/3 to a positive 1/9, negative 1/27, positive 1 over 81. Okay, so anytime that we have that sign going back and forth, okay, we know we're going to have negative 1 raised to some power. The question is it going to be negative 1 to the n, or possibly n minus 1 or n plus 1. Okay. Well, again, we want our first sign to be negative. Well, if I plug in n equals 1, well, that's going to give me negative 1 to the 1 is negative 1 like I want. Okay. So in this case, we can use negative 1 to the n. That'll take care of the sign. Okay. And then we can look at the rest of our pattern. And right, if we notice on the bottom, 3 is 3 to the 1, 9 is 3 squared, 27 is 3 cubed. Okay, so what we've got over here is 1 over 3 to the power n. Okay. And that would be our rule for the second one. And again, go ahead, write out a couple terms, make sure they do match. Okay. But that would be an example with an alternating sign. Okay, so that's enough with sequences. Let's go ahead and jump into series here. We'll change colors. We'll go red. So let's go ahead and do this first one. Again, I would just recommend writing these out. Okay. So again, we're starting with k equals 1. working our way up to 4. Okay, and our rule is we're taking k and squaring it. So we're starting with k equals 1 squared plus, and k is 2 squared plus 3 squared. And then our last one, we're going to stop at 4. Okay, well that's 1 plus 4 plus 9 plus 16. I believe that adds up to 30. Okay. So that would be our finite sum here. Okay, not too bad. Let's check out this next one. Okay, here we're going from 1 to 3. Okay, so our first term, we've got 2 things going on here. Starting at I equals 1. So this is 1 times 2 to the 1 plus, now we're going to I equals 2. So 2 times 2 to the 2 power, or sorry, the second power, plus 3 times 2 to the third. Well, now that's 2 plus 2 times 2 squared is 2 times 4 is 8. And then 2 cubed over here is 8 times 3 is 24. So we get 34 for our sum. Okay. And then on this last example, again, here's another alternating term. So just be careful with this, what we have in the numerator. Okay, so we're starting with 0 this time. We can start with 0, that's okay. So we've got negative 1 to the 0 over 0 factorial plus negative 1 to the 1. And we keep writing these out. We're going to go ahead and stop when we get to 4. Okay. So starting over here, evaluating from the left. So anything to the 0 power is 1 over 1. Okay, so that's just 1. Now we have negative 1 over 1. So that's negative 1. Negative 1 squared is 1 over 2. Okay. Now we've got negative 1 cubed over 6. So that's minus 1 over 6. Then we'll squish this in. Plus 1 over 24. Okay. Well, we'll move our way up here. 1 minus 1 is 0, so we can go ahead and cross that out. So we're left with 1/2 minus 1/6 plus 1/24. So if we put that with a common denominator, that's 12 over 24 minus 4 over 24 plus 1 over 24. Okay, and that looks like 9 over 24, and if we divide everything by 3, that would be 3 over 8. Okay. So again, just a couple examples on how to evaluate some of these sums, find the rules for these sequences. Hopefully you enjoy these. Again, we're just looking for patterns, trying to make some generalizations. So go ahead, get started on practice 1. Enjoy your half day, have a great weekend, and I will see you on Monday.